Hi, I hope you've enjoyed using planets. In this video tutorial, I'd like to walk through some of the features of the program. Maybe I can show you something you haven't already discovered. Let's get started. Let's launch planets and go to the Sky 2D view. If it's daytime, you'll see what looks like a compass with an icon representing the sun. Here, the sun is near the horizon to the southwest. Just tap the sun icon to show more information, such as the sunrise and sunset times. You can use the sun to determine which way is north. Just hold the device so that the screen faces up. Then rotate it so that the icon of the sun matches its direction in the sky. The top of the device is now pointing north. If your device is equipped with a compass, a button will be visible in the upper left-hand corner of the screen. Tapping this button will cause the display to rotate so that north on the display points toward the North Pole. This can be helpful if you are unsure of which direction north is, and when neither the sun nor the moon are in the sky to help orient you. If it is nighttime, the Sky 2D display will be dark and a map of the constellations will be visible. Any planets which are above the horizon will appear as an icon. As with the sun and moon, just tap on a planet's icon to display more information. You can use the nearby constellations to help locate a particular planet. Fortunately, the planets which can be seen with the unaided eye are brighter than most stars, which makes them easy to spot. If you are unsure of whether the bright object you are seeing is a planet or a star, another clue is that stars twinkle but planets do not. The reason is because stars are so distant that they appear as points of light, and this causes the stars to be affected by atmospheric turbulence much more than the disks of light that we see from nearby planets. Now let's try the Sky 3D display. You can move the view by dragging across the screen or pinch to zoom in and out. The circles indicate the angle of elevation from the horizon. The green plane represents the ground and the cardinal markings indicate the compass direction. Tilting the view downward, the ground becomes transparent, allowing you to look through the Earth and see what is below the horizon. This broken line represents the plane of the solar system, called the ecliptic. The sun, moon, and planets all lie in the ecliptic, because their orbits are more or less aligned on this plane. The 88 official constellations are shown. The ecliptic line passes through the constellations of the zodiac. In this example, the sun is in the constellation Pisces. The signs of the zodiac are only loosely related to the constellations which bear the same name. So the sun will not necessarily be in the constellation of your sign on your birthday. Constellations have no astronomical significance other than to provide useful landmarks for finding objects in the sky. If your device is equipped with a compass, then a button will be visible in the upper left-hand corner of the screen. Tapping this button will cause the display to rotate to match what you should see in the sky. This simulated iPad does not have a compass, so this feature does not work in this tutorial. If you move the sky manually with your finger, the compass will automatically be turned off, so you'll have to tap the button again if you want to turn it back on. Here's another interesting feature. Normally we see the sky using the narrow band of electromagnetic radiation which our eyes have evolved to detect. But there's lots of interesting information available at frequencies outside of the visible range. Let's select another range of the electromagnetic spectrum. Unlike visible light, infrared light is not blocked by the dust which pervades our galaxy. In visible light, the Milky Way is only faintly visible. But in infrared, the plane of our galaxy becomes a brilliant streak. The core of our galaxy is the brightest area, seen in the direction of the constellation Sagittarius. We know that a supermassive black hole resides at the core because we see the erratic motions of stars near the core using infrared telescopes. The visibility display shows at a glance when the sun, moon, and planets are above the horizon. In this example, we see that the sun rises at 7:35 a.m. and sets at 4:20 p.m. A yellow bar spans these times to indicate that the sun is above the horizon in this interval. The daylight hours are also colored blue to indicate that it may be difficult or impossible to see the moon or planets because the sky is too bright. The moon and the planets have bars of different colors to indicate when they are above the horizon. The Earth is always visible, just look down. A bar for Uranus and Neptune is not displayed by default because they require a telescope to be seen. You can cause these planets to be displayed with an option in Settings to be discussed later. The current time is indicated by a red line. In this example, the time is close to midnight, so it is on the extreme right edge. It will appear on the left edge once the time passes midnight. In this example, the red line shows that the Moon, Mars, and Jupiter may all be visible at this time. Tapping will cause more information to be displayed. For example, tapping on the sun will show the times that twilight begins and ends for 3 different standards. Tapping the moon shows the current phase and the dates of future phases. Tapping on the various planets shows more information, including the names of the moons. The globe display shows a 3-dimensional representation of the Earth, the Moon, or the planets. You can rotate the planet by dragging across the screen or pinch to zoom. When displaying the Earth, your location is indicated by a crosshair. The areas that are currently illuminated by the sun show a daytime image of the Earth, and the unilluminated areas use the nighttime image. This is a somewhat unrealistic view of the Earth, since there are no clouds, or a result of stitching together hundreds of satellite images, but selecting only cloudless tiles. The boundary between day and night is called the terminator, but don't worry, it has nothing to do with murderous robots from the future. Tap the button in the upper right to select a different planet, or the Earth's moon. Please note, we do not yet have orbital imagery of all the planets, so some graphics used on the globe display are an artist's extrapolation based on images we do have for the planet. Planets is designed to be simple, so there are very few options. Normally, you'll want to use the default settings. For instance, by default the location is determined automatically. But if the automatically determined location is wrong, or if you want to see what the sky looks like from another location, just set the automatic location option to off. Now you can enter your latitude and longitude manually, or you can choose the location, pull right, to select your position by clicking on a world map. If you have Wi-Fi or 3G access, you can also enter the name of the nearest city to set your location. Date and time are normally determined automatically. But if the automatic time is wrong, or you want to see what the sky looks like at a time other than the present, just set this option to off. Now you can manually set the date and time, as well as the time zone. Be sure to get the time zone offset correct, including daylight saving time adjustment, as this is important for accurate operation. Normally, only planets that are visible without a telescope are displayed. By setting the unaided eye option to off, you can force Uranus and Neptune to be displayed. Well, that's the end of this video tutorial. Thank you for watching it. If you have any questions or suggestions, feel free to send me an email. I'm very pleased with how popular Planets has been, and it's been very worthwhile creating this free application in support of education and science literacy.